Now it's my pleasure to introduce our speaker today. Melissa Floca is the Director of Strategic Partnerships at the CICORE Division of San Diego Supercomputer Center at UC San Diego. In her role, she brings together policymakers, practitioners, and researchers around complex challenges that require cyber infrastructure and digital technologies for solutions at scale. She works on a range of research projects and experimental education efforts related to disaster response and mitigation, including BurnPro3D. So welcome, Melissa. We're glad to have you with us today. And now if y'all could give us just one moment while we trade out presentations.
Thank you so much for that introduction. I'll need just a second to get my screen share going. All right, did that work?
Yes, we see your slides.
Fantastic. Well, thank you again for the opportunity to be here with you all this morning. As Mary Nell mentioned, I am based at UC San Diego at the WIFIRE Lab, where we develop science-driven technologies with the fire management community. Our expertise at the lab is on the cyber infrastructure side, so all of the things that you don't see that make technology work. And we work with the fire management community to make sure that we are trying to design technology that aligns to what people need, what they want, things that are useful and usable. So we take a human-centered design approach in all of the work that we do, and have had an opportunity to speak with some of the folks in this conversation already today about their needs in prescribed fire, and look forward to lots of opportunities to continue those conversations. BurnPro3D, as Mary Nell mentioned, is a decision-making tool to plan safe and effective prescribed burns. And it's a web-based interface, and it is still under development. So it is funded by the National Science Foundation, and it is in the early stages still, but the intention is that it will become a platform that can give users easy access to next generation fire science to plan and implement prescribed burns. So really an attempt to break down the silos that we often have between data and models and user interfaces, and make it easier to have the science that's available at your fingertips when you're writing a burn plan, or when you're getting ready to implement a prescribed burn. So some of the folks who are key collaborators on this project include Ilkay Altintas, who's the director of WIFIRE Lab, Russ Parsons at USFS, Yolanda Hill, who is an artificial intelligence expert at USC, Kevin Hires, and Rod Lynn, who is responsible for the fire modeling on our team. And so we do have partners from the Forest Service, from USGS, from Los Alamos National Lab, as well as dozens of other collaborators from universities and from the private and nonprofit sector. It's a large collaboration, and it's a relatively new collaboration. So we've been working on this project together as a team for about 2 years now. And BurnPro3D has 4 pillars that reflect the work of many of these collaborators, the longer term work of many of these collaborators. So we use fast fuels for the fuel models in BurnPro3D. And for folks who aren't familiar yet with fast fuels, I'll talk a little bit more about that. But I think the important piece of fast fuels is that it's high resolution and it's 3D. So vegetation is represented in 1 meter cubes, so that they can be ingested into the fire models. Then we have our True Trees LiDAR-derived tree positions and heights, where we use aerial LiDAR to improve fast fuels, to improve the position and heights of trees based on aerial LiDAR when it's available. And then in BurnPro3D, you can use what we call drip torch, which is a application for custom ignition patterns. And then basically the vegetation model and the ignition pattern that the user has designed get ingested into the quickfire prescribed fire simulator to model fires under different sets of environmental conditions. And then BurnPro3D takes all of this science that sits under the hood and makes it possible for users to do fire models and then to interact and visualize those fire models to understand fuel consumption under different conditions. So I'll walk you through the interface itself in a few minutes here, but just to give you a sense of the user journey through the website, we've designed this is that you first select your burn area and you define a wide range of environmental conditions that you're interested in seeing fire models for. So conditions that go beyond maybe what you would think about as an ideal burn window, so that you can see what happens to fuel consumption under different combinations of environmental conditions and ignition patterns. And then that information that the user inputs, we take it and we run something that's called an ensemble in BurnPro3D, where basically we're generating a fast fuels tile for your burn unit, that 3D vegetation model. We're running the simulations based on all defined in QuickFire, and then we're calculating fine fuel consumption at surface, mid-story, and canopy level for each of those fire models, and then that is returned to the user so that they can create a burn scenario where they can define burn objectives in terms of surface, canopy, and mid-story fine fuel consumption. So, for example, that they would want 60% to 90% fine fuel consumption in the surface fuels, or whatever the different burn objectives might be for the burn unit. And then what BurnPro3D does is it identifies the environmental conditions and ignition patterns that then the user can visualize each of those burns and explore the different outcomes of the models. So just to give you a bit more context on fast fuels. Fast fuels is, like many of the pieces of the pillars of BurnPro3D, it is continuing to be developed as well. And BurnPro3D is a web-based application. So as new versions of fast fuels come out, as new versions of QuickFire come out, those get integrated under the hood into the workflows that the website uses. But for now, the version of fast fuels that we're using in BurnPro3D, it uses best match FIA plot data to distribute trees in the region of interest. The canopy fuels are calculated using species-specific equations for fine fuel weight and crown volume. And then the individual crowns are voxelized. What that means is that they're put into these cubes that you see. So you have a 3D model of the vegetation at a 2-meter horizontal resolution and a 1-meter vertical resolution. And then in the fire model, what's in those cubes is what's being burned. So we're modeling the fire as it moves through the fine fuels that are in those cube representations of the burn unit. And the surface fuels come from Scott and Bergen, and they're resampled to 2-meter resolution, but they can be swapped out for other surface fuel data as well if you have other surface fuel data that you would like to use. And so that's how the fuel model is created. And then the LiDAR on-ramps that we have improve that vegetation model based on aerial LiDAR. And so we look at the tree positions and tree heights and canopy areas, and based on those aerial LiDAR derived tree attributes instead of the FIA plot data, and we adjust the fuel model correspondingly to that data. And this is an important part of the scientific agenda that we're continuing to pursue because we're working on lots of different approaches to on-ramping terrestrial and aerial LiDAR to improve fuel models down the road. But for now, we're only we're only using this aerial LiDAR on-ramp at the moment in the website. And then after the vegetation modeling piece, we have our software tool DripTorch that generates spatiotemporal ignition patterns and exports these timed path coordinates for the prescribed fire model. And this is all basically input by the user. So it takes into account the firing technique that you'd like to model, the device that you'll be using, and the blacklining operations for the unit. It's of course not perfect, because sometimes the ignition patterns that burn bosses have in mind don't align to what that software tool can design. And in that case, we can also do custom ignition patterns and upload those instead of the DripTorch ignition patterns. But typically, at least as a first cut, the ignition patterns designed in DripTorch give people a good sense of what the fire might look like. So I'll show you this in the interface itself a little bit later, but basically you go through and you make a number of decisions about how you're planning to ignite the unit. And then you can see a video of the pattern that you've created. So all of that gets ingested through the workflows in BurnPro3D into QuickFire, and we use the supercomputers at the San Diego Supercomputer Center to run the models. These models are very different than the models that you might be used to using. They're very computationally intensive, and so you might be used to running a model and seeing it, in a couple of minutes, depending on the size of your burn unit and the amount of fire behavior that's happening during the burn, and the amount of topography as well, because these models are 3D. You could definitely, this could definitely take a lot longer, but this tool is designed for planning. And so we hope that even if you have to wait a day or even 2 days from fire models to come back for burn units, that's something that would be possible within the burn plan preparation process in many cases. So QuickFire uses all this high resolution fuel data and the user-defined ignition patterns to predict fire spread under different combinations of environmental conditions. And the 3D fuels allow us to really understand the effect of surface to canopy spacing and the effect of fuel gaps, so that those are captured in the fire model as well. And then this is a self-determining modeling of fire spread and the atmospheric response to fire. So it can quantify the impact of different ignition strategies on fire intensity and fuel consumption. And then there are also outputs on smoke lofting and emission of CO and PM 2.5. So these are just visualizations of what is happening in the fire model for each one of the fires that is modeled. And then here you can see this is just a visualization of a fast fuels tile for a burn unit in Yosemite National Park before the fire was modeled, and then after the fire was modeled, where you can see in red all of the places where you had fuel consumption in this particular burn. All right. So as I mentioned before, we've tried to design a process that best reflects to our understanding how data and models can support the burn planning process for there to be a more explicit connection between your burn objectives in terms of fuel consumption and the environmental conditions that you're considering for your weather window, as well as the ignition strategies that you're considering and that you're planning to pursue. And so just to give you a sense of our own timeline, because I do want to underscore that feedback from the fire community has been really important in informing our work, but also that we know we need more feedback, and that BurnPro3D is still under development. We're ready for focus groups and some usability testing, we're working to put out a beta version of BurnPro3D sometime this year. But we started this process back in January 2022, looking at prescribed burns at Eglin Air Force Base and doing a lot of work on whiteboards and through sessions from feedback from fire managers. And today what we have is a beta version, or something close to a beta version of BurnPro3D as a website. And so, I'm glad to be here today with all of you, and look forward to being in touch in the future as well, because we're at a part in our process where we've learned a lot about the kinds of cyber infrastructure that we need to build to make this useful and usable. But we have quite a way to go, and look forward to lots of opportunities to discuss with you and with your colleagues. So we have, as I mentioned, out this version of BurnPro3D 0.1.0, and we're getting ready for usability testing for burn planning with version 0.2.0. And then by the end of this National Science Foundation grant, when it ends this year, we hope to have a version that is ready for beta testing at 5 or 6 different demo sites across the country. So it still won't be a tool that's quite ready for use in all geographies, but we're aiming for it to be working well in at least 5 or 6 of our demo sites, and to learn from the challenges in those demo sites to improve it for widespread use. And so we've already heard a number of things from people, like they want the ability to draw burn units. They want changes to drip torch that work better for places where we have contours. People want to be able to modify their fuels themselves based on what they know about their own location and things that have happened there on the ground that aren't included in the data already. And of course, people want the ability to connect BurnPro3D to fire weather and spot weather forecasts, as well as longer term weather forecasts. There's also, we've heard an interest in risk metrics and changing and improving visualization. We spend a lot of time trying to think about how to visualize things in a way that makes sense. And we've also heard from people that, they would want a way to basically share projects and share information from their burn models with their colleagues. So they need mechanisms to share the burns that they're creating. And I just mentioned that I'm going to, I think, pause here and see if there are questions before I show the site itself, but I wanted to give you a sense of the kinds of things, the kinds of feedback that we've already heard and that we'd like to hear more of, so that you have that in mind before we look at the website itself. But yeah, I think I'll pause here before I do that and see if anyone has any questions that they'd like to ask before I move on.
Yeah, we have a couple questions in the Q&A box so far.
Okay.
Josh was asking, can it be used in the central hardwoods fuel types?
So that's a great question. And we get a lot of questions about fuel types that I'm not always the best person to answer. Yes, I think it can be, I think quickfire in general and fast fuels in general will work well for central hardwood fuel types, but I will reconfirm that with our team, Josh.
Okay.
And Mary Neil, will you help me be able to be in contact with people if there are follow-up questions like this?
Yeah, we can post your email address into the chat if that works.
Okay. Yeah, that's great.
Perfect.
Yeah.
Okay, so we're getting some more questions coming in now. Kayla asks, you mentioned the surface fuel model can be customized. Can the overstory fuels such as trees also be customized. LiDAR inventories and FIA information can quick out of date if a mechanical thinning treatment occurs after the LiDAR/FIA, but before the prescribed fire.
So we do not have a way that you would be able to customize through the website interface based on mechanical thinning treatment right now. Right now, we need data to basically to on-ramp into fast fuels. But this is a question that has come up before, and I really and we collect all of these kinds of questions to think about techniques that we can add into the website so that this can be possible in the future. So thank you. No, there wouldn't be a way right now to change the fuel tile based on a mechanical thinning treatment, but we could certainly build something like that that would let you reduce fuel density, kind of manually reduce fuel density in your vegetation model. Thanks, Kayla, for that question.
And Lisa had kind of a follow-up question to that. So what are the environmental variables that are able to be entered and manipulated?
Great. I'll show you that as when we walk through the website, but basically you choose fine dead fuel moisture, different ranges of fine dead fuel moisture and live fuel moisture, as well as wind speed and wind direction. Those are the only environmental inputs at the moment that we're using in the setup for the models.
Awesome, thank you. And then we've got from Jonathan, do the emissions and smoke production feed back into the fuel shading to moderate fire behavior?
I do not think so. I don't think so. I will have to ask our quickfire team, but there's the connection between the atmosphere. There's a connection between the atmosphere and the fire behavior, but I don't think that there's between shade and fire behavior, but I'll ask Jonathan.
Yeah, that might be a little bit more advanced than where it's at right now. Maybe one day.
I just don't know. Quickfire might do that, but I actually just don't know the answer to that question.
I gotcha. So where do you anticipate the initial demo sites to be, or where they might be?
So we're considering Piedmont, New Jersey Pine Barrens, a couple of places across the Southeast, and then somewhere in Arizona and somewhere in California. So we have some sites under consideration, but if people are interested in reaching out and would like to be part of our demo network, then we'd love to hear from you. And by demo, I guess I want to just clarify that the demonstration is the demonstration of the modeling. So, demonstrating that that you're happy with the way that fuels are being modeled, that the fire model outputs make sense to you based on your own experience as a practitioner in that place. And so the demo network does not mean demonstrations of fires. It means demonstration of the use of the tool for burn planning.
Gotcha. And then one that kind of follows up from that one is, how long does it typically take for a simulation to run? Seconds, minutes, hours?
So it can take a while. When you set up an ensemble, you might be setting up, say, anywhere from 36 to 500 or 600 fire models with different combinations of environmental conditions and ignition patterns. All of the models run in parallel. So you're not waiting for one model to run at a time. They are all running in parallel. However, there's just a lot of computation for modeling both vegetation at this scale and then fire behavior in vegetation at this scale. So, if you're doing if you're doing models on, say, 5 or 10 acre units that are flat and there's not a lot of fire behavior, something like maybe the burn unit that I can see on Mary's background. If you were modeling a fire on that burn unit and say it was a 10 acre unit, then you might be able to look at, 200 models of fires on that unit in, say, 4 hours. If you wanted to model, if you wanted to model something that was like a 1,500 acre unit and there were a lot of hills, and some of your models had a considerable number of escapes and a lot of fire behavior, then you could, it might take a day or might even take 2 days for those models to come back, because every time there's fire, there's computations, and the more fire there is, the more computations there are. So yes, it could take a couple of hours. It also could take a day or two, depending on the burns that are being modeled.
Gotcha, that makes sense. And Taro asks, how are winds obtained and factored into the model in terms of outputs and firing operations?
Sorry, how are winds obtained and factored into the model of the outputs of fire operations? Okay, so Taro, I'll walk through how we're modeling this in the interface itself. Winds are steady at 20 feet in the model. That's what's being modeled. QuickFire can do things that are much more complex than that with winds. So you could take data, QuickFire itself used outside of the BurnPro3D interface. You could take data that you had on winds from a particular place, and you can use that in QuickFire to model fires. You can also, you can set different winds and different heights in different places across the burn unit in QuickFire. But in the BurnPro3D interface itself, at the moment, all that's happening is that winds are steady at 20 feet, except for the wind that is a result of the fire behavior itself. So winds are steady at 20 feet, but then also all of the wind that results from the fire behavior itself is modeled in QuickFire. I mean, that's what QuickFire is doing, right? And so in terms of, I don't think I understand the second piece in terms of the outputs of firing operations, but maybe I already answered that.
Yeah, I'm not sure about that part either. Taro, if your question was not answered, you can maybe type in the Q&A anything that's left over from that. But I think I would think that just about covers it. Then we have 2 questions about scale. So Chuck asked about if there's a minimum burn unit size to leverage BurnPro3D. And we also have a question about, are there spatial scale limitations, i.e. it can't handle data above a certain size or is not valid below a certain size of burn. So could you tell us a bit about the scale that it can handle, that can model?
It's fine for modeling. It's fine for modeling at a small scale. Yeah, I mean, I don't know. I guess I don't know if there's a limitation on the small side, but for sure, if you wanted to do like a 300 by 300 meter unit or something like that, that would be fine. And probably smaller than that too. I just don't know actually the answer to that question. We can do burns that are much bigger. They just take a really long time. So, for example, if we wanted to do a burn on a 10,000 acre burn unit, that would take a very long time. We can do it, but it would just take a very long time. I've been using BurnPro3D mostly for units under sort of 500 acres. And that's, at the moment, our focus is for it to work, pretty seamlessly up to like a 500 or a 700 acre burn unit. And we know that things will slow down considerably and might not make a ton of sense for people when you get to really, really big prescribed burns, just because the amount of compute that you need for that, it's also not always going to be cost effective at that point. Okay. I think I answered most of the questions, but I saw some others come up. Mary, do you want to keep helping me work through them?
Yeah, I was thinking we could cover one or two more, and then if you want to go into the model. So Chuck is asking about how we sign up for usability testing.
Okay. Do you have the link for that handy?
Yes, so David will be posting into the chat 2 links, one with a flyer about more information about BurnPro3D and then how to get involved, and also the sign up form where you can stay in contact about usability testing and also, stay up to date on information about BurnPro3D. I don't know if you have anything else to add to that or if that covers it.
No, that's great. And I see that there's there's a couple of different questions on QuickFire. And for the more technical pieces of QuickFire, I'm not the right person to answer that, but I can ask the QuickFire team for some resources and some of their latest publications related to QuickFire, and I can give those to you to circulate to people as well, if you'd like, Mary.
Okay, sounds good. And then I think the last one for now is, are models available for worst case scenarios, i.e. freak windstorms, lightning, etc.?
So I assume that you mean like in the context of a prescribed burn where there was a windstorm that you weren't expecting or lightning that you weren't expecting during a prescribed burn. That's not that is not something that we're modeling. So, and I'll go through this when we go through the how the website flow is set up itself. But basically, you're giving us find a fuel moisture, live fuel moisture, wind speeds, and wind direction, and that's what we're modeling. So something unexpected happening outside of those parameters that you give us during a prescribed burn is not. It's not in the model, but if you wanted to do a model, say where you said winds were 30 miles an hour, then you can certainly run BurnPro3D and see what happens when winds are 30 miles per hour.
Right. Could run, a single scenario with 30-mile-per-hour winds, but couldn't start with 5 and then increase to 30.
No.
Okay, I think we'll save other questions for later to make sure that we get some time for your demonstration.
Maybe I'll just say one more thing about all of these questions, which is that we're the tools that sit behind BurnPro3D, like QuickFire and Fast Fuels, can do a lot of things. And we're trying to find the simplest way to use them in a website interface where the results are still meaningful to help in the burn plan preparation process, but that there's not so much complexity in the way that you set up the fire models that it becomes too costly to use or it takes too long to use. So I think, hearing these questions about wanting to modify fuels, about wanting to, include different things that could happen during the day during a prescribed burn are really helpful for me to hear, because I think we're looking for the right place on the spectrum where we can provide a tool that has enough complexity that it provides information that's meaningful, but not so much complexity that it bogs things down and makes it hard to use and hard to run. And so please keep the questions and comments coming in that vein. It's very helpful to hear them. Okay, then I think if it's okay with everyone, I'll pop us into the website itself and maybe just walk through. I know we're getting close to the end of time, so I'll just walk through relatively quickly because there are one or two other things I wanted to show you as well before we end today. And And please do, use the link in the chat if you'd like to be part of future conversations where we have more time to go into the usability with you and get your feedback. But for now, let me just show you. So this is the one version of the BurnPro3D website, where, like I said, it's designed so that you can come in and you can say that you want to design a burn, and then you can design a burn for any burn units that you've loaded into the platform. So you do need GeoJSONs or shape files of some sort for the burn units. And then you would name the burn ensemble. And you would say, okay, I have this burn unit in England loaded up. Takes you to your burn unit. You can see it. And then you get ready to model a fire on that burn unit. You come in and you can see this is the Fast Fuels 3D vegetation model for that burn unit. There's a little explanation for folks on how this data was created. Then you can, if you have a custom ignition pattern, you can upload it. Otherwise, you can design an ignition pattern in Drip Torch. So you pick the direction that winds are coming from for your burn that you anticipate, and then you make some different decisions about how you would like to carry out your burn in terms of depth and stagger and the ignition type and so on. And then you can see a simple animation of the parameters that you've put in. And so, for example, on this unit, it's going to take me 2 hours. I'm going to have 3 igniters. They're going to be walking across the unit at 1.8 miles per hour, and the stagger is going to be 20, and the depth or the spacing is going to be 20 meters apart. You can see there's a black line. You can make it larger if you wanted to. And vegetation is being removed from the vegetation model. There at the black line, you have a control line as well. You can also make that wider if you wanted. And then when you're happy with your ignition pattern, maybe I want to get things done a little faster. So I add an igniter. Maybe I actually think they can walk a little bit faster on this unit, and maybe I'm okay with spacing them at 30 meters instead. And now I can see that my total ignition time has come down to 1 hour and 4 minutes based on those new parameters that I've input. And I can see again the animation of that ignition pattern. So once you're happy with your ignition pattern, like we discussed, you come and you include all the different environmental parameters that you'd like to model. So what gets modeled is every combination here. And so maybe I decide I don't need quite that many. Maybe I don't need quite that many inputs. I'm not interested in 1 mile an hour or really 3 miles an hour. And I'm not interested in 35% fine dead fuel moisture or even 20% fine dead fuel moisture. And maybe I only want 100 and 110% live fuel moisture. When you're happy with all the different environmental parameters, then you click next and you can review the burn that you set up, all the parameters that you input, and then you send that off to model in QuickFire. And this would probably take 5 hours, maybe a little bit faster to come back, but something like that, 3, 4, 5 hours to come back. And then what you get back, you go into the viewer and you can see here we're viewing an ensemble that has 36 runs. The combinations that were used were 5, 10, 20, and 35% fine dead fuel moisture, 5, 10, and 15 mile an hour winds, and 3 wind directions. And I can see that, for example, I got some of my runs with very low surface fuel consumption down there at 18%. And I can say that's probably not going to be acceptable to me. I'm going to want at least 65% surface fuel consumption. And maybe for mid-story consumption, I would want something closer to 15%. And I'm fine with 0 to 8% canopy consumption for fine fuels. And then I can now see the different combinations of environmental conditions that gave me burns within those fuel consumption ranges. And I can come down and I can look at the model for each one of those burns. So for example, here's one that had some escapes. This was, let's see, this was a find dead fuel moisture of 5%, live fuel moisture of 100%, wind speed of 15 miles an hour, and wind direction 285. 98% of the surface was consumed and 28% of the mid-story was consumed. So that might be a little bit out of what I really want for my fuel consumption ranges. And I can look at a visualization of the 3D fuels at the end of the burn. You can see the gray is everything that burned. You can come in here and you can see where fire was getting up into the canopy for some of these trees. I know Zoom, this probably doesn't look great coming through Zoom. I'm sorry for that. But you can also look at a time lapse, and you can go in, and I think Mary Nell was going to provide as well the website. You can look at some of this stuff on your own there too. But you can see a time lapse of the fire, and you can see in the model where you started to get escapes, where you started to get some escapes. And so, yeah, that's basically where we are at the moment with the way that we're using the data and the models and the inputs from users to model burns. And definitely still working on things and trying to find visualizations that work, and also making improvements to parts of the tool. And so I want to end maybe by talking about a couple of things that are still under development. I already talked a bit about our on-ramp and how we're using aerial LiDAR to modify the fuel model. You can see that there are some important differences in the fuel model with and without the aerial LiDAR data when it's available. We're also working to improve drip torch for places where there's topography. And so I'll just show you, this is, will come out, I think, in the next release of BurnPro3D, where we'll have the contouring feature in drip torch in the ignition patterns that you design, as well as the ability to do two-step ignitions where you do different ignition patterns across different parts of the burn unit. And then another thing that we're working on is both visualization and on-ramping of terrestrial LiDAR. So one of the things that we have ready now, if you do have terrestrial LiDAR, is the ability to have it in your version of BurnPro3D so that you can see and that you can share with colleagues terrestrial LiDAR where it's available. And then of course we're working on using terrestrial LiDAR to improve surface fuel representation in fast fuels as well. But here's just a quick video of the LiDAR visualizations that the visualization tool for LiDAR that we're working to make available in BurnPro3D. And I think I'll end there and see if there are questions based on that.
We have a lot more questions coming in. I'll start with, there's two people that have asked about the availability of the final product and if it'll have a cost associated with it. So from Jordan, we have, will the BurnPro3D be publicly available at its final stage? And will there be a cost or subscription associated with the product?
So that's a great question. We don't know the answer to that question. So our goal as a research team is to make it as widely available as possible. We want it to be available to anyone who wants to use it. We just don't know how to pay for that. And so the business model, the way that this will be made available in the long term, I don't know. And that is part of what our team is working on, is to understand, to understand the best way, first of all, to understand what the costs are. So We don't know. Right now, we're running all of these models on our own supercomputers. So in a way, although those computers are not free, it's free. It's free to us to run all of these models. And of course, long term, that's not possible at wide scale use. So we also don't know how much the real cost is of running models. And we know that these are really important questions, and we do have folks on our team working to figure out, how to do this as cheaply as possible, how much it costs, and what some of the ways could be where we would be able to make it widely available.
Awesome, thank you. And then we had a question, can you use this in an AAR or after action review situation to review a prescribed fire or a wildfire that's already occurred?
I don't think I know the answer to that question. But if anyone wants to chime in and talk more about this, we certainly can.
So I would think this would have to do with putting in the inputs of what was like the weather inputs of what was happening that day and their fuel inputs. I would think, yes, this could be used for an AR. You would just put in those weather inputs that happened during the event and then see the model and run the AR accordingly.
I mean, there are lots of limitations to models, right? So models are only as good as the data that goes into them. And I think, whatever purpose that you're using this for, one of the things that we're working very hard on is making clear the assumptions that are being made. What data is being used, when there are assumptions, what are those assumptions, and what are some of the kinds of biases or overstatement or understatement of fire behavior or fuel consumption that can happen as a result of that. And so that's another thing that we love feedback from people on through this process is, are we explaining sufficiently what's happening, what the science is doing and what the models are doing, so that as a practitioner, you can understand when you can take the information with the appropriate grain of salt, understanding, how the models were developed, right?
Right. The output might not be exactly what happened on the landscape, but could be beneficial for viewing the conditions. Okay, and then we have one looking at air quality. So can BurnPro3D be used for determining when to burn to not impact air quality, I'd say, as much? For example, see, avoiding conditions like low winds. Yeah, so is there any way to use BurnPro3D to kind of use it as a smoke management tool?
Not right now. We have not included anything about smoke in this version of BurnPro3D, but we're only using outputs from QuickFire based on fine fuel consumption right now. That's the only thing that we're using. But QuickFire does have other kinds of outputs. So there are QuickFire outputs related to smoke and emissions that we can integrate into future versions of BurnPro3D. So it would be great to continue to hear from folks around how they might like to use data on smoke and emissions, or visualizations on smoke and emissions under different combinations of weather conditions and ignition patterns in the burn approval process. We haven't, as a team, explored. I mean, lots of people on our team work on smoke and emissions, but we haven't, as a team, explored how to integrate that into BurnPro3D, and I'd be excited to talk more about that.
So with what you just said about the inputs, that might have kind of answered this question. Ryan asks if there would be an ability to select a fuel type of logging debris for those who are doing site prep burning.
Could you maybe tell me a little bit more? So I guess if maybe a short answer to the question is that we're we are not modeling like any of the site prep at the moment, and we would have to think about how to add that capability. We haven't thought about that yet.
Yeah, so I think this would be including, if you mentioned that it is maybe just modeling surface fuels for now, and this would be including like slash as a surface fuel, like slash and logging debris. So I got the idea that maybe it isn't capable of doing that, at least right now. Is that right?
Probably not. Yeah.
Okay.
But we can definitely, I'm happy to talk more about that and understand that question better offline if you'd like.
Okay. And I did put your email into the chat box. So anyone who's has additional questions, please feel free to reach out to Melissa. And from Sandra, at what speed does the model play back? Is it minute by minute, or does it just show like a completed state of the area?
Okay, so we're modeling or we're basically capturing fuel consumption at lots of different time steps throughout the model run. We're showing you we're showing you is fuel consumption, that we're calculating fine fuel consumption at the end of the model run. The model run is ignition time plus an hour standard. So however long your ignition is plus 1 more hour, and then we're calculating the fuel consumption at the end of that time period for surface fuels, for mid-story, and for canopy fuels. But if people don't think that ignition plus 1 hour of burn time is the right amount of time to run the model for, I'd love to hear more about that too. Our intention is that lots of the important fire behavior would already be done, but that might not always be the case. So maybe that's something that people need to be able to modify for their own burns. Sorry, I might have lost track of the question. Did I answer the question?
I interpret it as to mean like, so the actual output of the model, do you see just the final area burned, or could you look at a certain time of the day and say, this is what the fire looked like at this point? That was my interpretation.
You can see right now, you can see a 3D model of fuel consumption at the end of the burn time, and you can see in 2D where the burn was and what was going on in the surface fuels. That 2D visualization is a visualization of the surface fuels at any point throughout the model. But we've gotten a lot of feedback on all of that, and we're trying to develop visualizations that give you more of a sense of what's going on at different points in time, because we have the data, we're just not visualizing it through the interface right now.
Okay, thank you. We've got time for a couple more questions. For anyone whose question we don't get to, please feel free to use the email in the chat to reach out to Melissa. People are just very interested in this, which is great. I love seeing all these questions coming in.
And they're really helpful for us too. So I appreciate the questions and the engagement, and hope that people will reach out and sign up to participate as we do some more usability testing.
Mm-hmm. Are there plans to integrate this into IFTDIS, which is the Interagency Fuel Treatment Decision Support System?
I don't think so. I mean, at this point, we're just, like I mentioned, we're still in the early stages of our own work. And so right now, our goal, for this year is to have a tool that people think is useful, that people think is usable, and that's working well in 5 or 6 of our demonstration landscapes. And then I think some of these longer term questions of, how does it become widely available, and how do you pay for making it widely available, and where will it be available? Hopefully that will flow later from, based on how useful and how usable we can make this for people.
Great. And I'll end with one more question, which I think is more of a clarification question that a couple people might have had. When you say drip torch, is that also synonymous with aerial ignition?
So yes. So we just call that little piece of software drip torch, but yes, So right now, the only firing techniques that are available in this version are dashes and lines, but there will be dots and aerial point ignition available soon too.
Okay, great. Thank you so much. And well, that's about all the time we have for today. Thanks so much for everyone's questions. I'm sorry we couldn't get to all of them, but again, feel free to reach out. Contact information is available on the slide as well as in the chat. And Melissa, thank you so much for joining us to share your work. Thank you everyone for joining in, and we hope that this webinar will be useful in your management programs. Have a great afternoon.
Thank you. Bye.